right, we found derivatives for bases other than e's. Now let's focus on integrals. At the end of this lesson, you'll be able to evaluate an integral for a base other than e. All right, we've got one formula. If I've got an integral of e to the a to the u, and this actually should say du right there, then my integral will be a to the u over ln a plus c. If you recall, when we had e to the u du, my integral was just e to the u. So it's pretty much the same thing. The only thing that we have to do, again, we have to deal with that ln a. So we'll divide by ln a. Okay. One thing I want you to look for, because sometimes we just get a little bit stuck on these problems, whenever you see a constant base, whenever you see 5 to the something, 7 to the something, you're always going to let u be the exponent no matter what. So be looking for that when you're looking at these problems. All right, we've got to find the integral of x, 3 to the 4x squared. A lot going on in this problem, but I see a constant base. The second I see a constant base, we're going to let u equal the exponent no matter what. Okay, so my du, my derivative of 4x squared, will be 8x dx. Notice that I have the x, I'm missing the 8, so I'm going to put a 1/8 on the outside. So I'm going to get 1/8. 3, I did nothing with the 3, so it's going to stay there. The 4x squared was my u. The 8x dx, I get to replace with du. All right, so from here I'm going to bring my 1/8 down. Okay, the 3 to the u, the integral of 3 to the u is just 3 to the u. And then we're going to divide it, though, by ln a. So we're going to divide it by ln 3. So the way that I'd wrap this problem up, on the top I have 3 to the u, so 3 to the 4x squared. And then on the bottom I have 8 ln 3, and then plus c. So that would be my answer. All right, this next one I have 7 to the negative 3x dx. Not sure what to do. I notice that there's a constant base in the problem. So we're right away going to let u equal the exponent. So u will equal negative 3x, which means my derivative of negative 3x is negative 3 dx. I don't have a negative 3 sitting in my problem, so I'm going to put a negative 3 on the inside, which means we need to put a negative 1/3 on the outside. So we've got negative 1/3. I've done nothing with the 7, so the 7 is still there. The negative 3x became my u. Negative 3 and dx, when I put them together, get to be replaced by du. Okay, so bring my negative 1/3 down. The integral of 7 to the u is just 7 to the u, but we have to divide by the natural log of 7. Okay, and then cleaning that up, on the top I have negative 7 to the u, to the negative 3x, over 3 ln 7, and then plus c. All right, next one. Looks like a lot's going on in this problem. We've got 4 to the 5 tangent x times secant squared x dx. But I notice that I have a constant base. The second that I see the constant base, I know that I'm going to let u be the exponent, so I don't need to worry about anything else in the entire problem. All right, my du, the derivative of 5 tangent x will be 5 secant squared x dx. All right, I notice that I have secant squared x. I'm missing the 5, so 5 on the inside, 1/5 on the outside. So 1/5. We've done nothing with the 4, so the 4 is still there. The 5 tangent x was my u. 5 secant squared x dx, we get to replace with du. So bring down the 1/5. The integral of 4 to the u is just 4 to the u, but I have to divide it by the natural log of 4. And then just finishing this up top I'm going to have 4 to the u, so 4 to the 5 tangent x over 5 natural log 4 plus c. Alrighty, last one. This one's just a little bit different because I have limits, so we want to make sure that we deal with those. First thing, I see a constant base, and we actually should have a dx on this right now. I have a constant base, so the second I see I've got a constant base, we'll let u equal the exponent. So du will just equal 1 dx. I've got it, so if you would like to replace this, we could actually make it 4 to the u du. If you don't need that step, don't use it, because since u and x are actually the same thing, it doesn't really matter which variable I have there, but I thought some people might want that step. So anyway, the integral of 4 to the u is 4 to the u. So 4 to the u over the natural log of 4. So this will be 4 to the x over the natural log of 4. This time I'm not going to put plus c because I actually have limits, so I'll evaluate it at 2 and negative 1. So if I plug 2 in, I will get 4 squared over natural log 4, and then minus, if I plug negative 1 in, I'll get 4 to the negative 1 over natural log 4. So let's see, from here I'll get 16 over natural log 4 minus 4 to the negative 1 over natural log 4. To simplify this just a little bit, again, I'm going to factor out 1 over ln 4. And when I do that, I'm going to get 16 minus 4 to the negative 1, which is actually equal to 1/4. And cleaning that up just a little bit, I'm going to get 1 over natural log 4. 16 is actually 64/4. So this will actually be 63/4 left. So my final answer will be 63 over 4 ln 4. And that will be my final answer. So hopefully now you can take the integral when we have a base other than e.